Today we're going to be finding the area of regular polygons. The first thing we need to review is what is a regular polygon? A regular polygon has all of its sides congruent to each other and all of its angles are congruent to each other. That's a vocab word that we learned a while ago, so just in case you forgot, all of its sides are congruent and all of its angles are congruent. There's a special formula, it's a janky looking symbol. There's a special formula that works just for regular polygons. But there's some important vocab that we need to talk about first. So this point right here is the center of your polygon. That's the center point. And so the distance from the center to the vertex, this distance right here is called the radius. So just like the radius of a circle is the distance from the center of your circle to the side of the circle, the radius of a polygon is the distance from the center to the vertex. This is a side. And the newest and most important piece of a regular polygon is this segment right here. It's the distance from your center to your side, and it has to be perpendicular to your side. It has to create a right angle with your side. This is called the apothem. This is called the apothem. It's the distance from the center to your side, and it's perpendicular to your side. What's happening is this is a radius. This is a radius. I've just created an isosceles triangle. These radii are both congruent. So this is an isosceles triangle. This apothem is the height of that isosceles triangle. The special formula for finding the area of a regular polygon, for finding the area of this whole entire shape, we are going to multiply 1/2 times the apothem times the perimeter. So A in this formula stands for apothem, the length of your apothem. P stands for the perimeter. And how do you find the perimeter? Perimeter is when you add up all of the sides. So you could take the length of the side and multiply it by the number of sides of your polygon. The last thing is sometimes we are going to be either given the radius, or we'll be given the side length, or we'll be given the apothem. And so we have to find the other pieces of information. And we're going to need this angle up here. We are either going to use SOHCAHTOA, trigonometry, or we're going to use a special right triangle. But we need to figure out what that angle is. So if you think about, I have all of these radii. So I've just created a bunch of congruent triangles all the way around. That's 360 degrees. And so if I want to figure out the measure of just one of those angles, I'm going to take 360 degrees and I'm going to divide it by the number of sides. And that's going to give me that central angle. That's going to give me how many degrees are in this angle at the top of that triangle. And so once I know my central angle, then I can just divide it by 2, and that will give me the measure of this angle. So this is my central angle divided by 2, half of my central angle. So I find my central angle by taking 360 and dividing it by the number of sides. And then once I know my central angle, I'll divide it by 2, and that will give me the measure of that angle. So let's work an example. Find the area of this regular polygon. This is a pentagon. It has 5 sides, and I want to find the area of this polygon. So I know one of the side lengths, but I don't know the apothem. So what I'm going to have to do is first figure out what this angle is. So I'm going to find my central angle by taking 360 and dividing it by the number of sides. So 360 divided by 5, 72. And then take 72 and divide it by 2, which is 36. And that is how I get the measure of this angle. That angle is 36 degrees. We talked about how these are isosceles triangles. And so if this is an isosceles triangle, this apothem is dividing this side into two congruent pieces. So if this whole entire side is 10, that means that this little nugget is going to be half of that, which is 5. And I'm going to figure out what my apothem is. So I'm going to call my apothem x. I need my apothem. It's going to be x. Since this angle is 36 degrees, I'm not going to use a special right triangle, but I am going to use SOHCAHTOA. 5 is my opposite side. X is my adjacent side. And so I'm going to use tangent. Tangent of 36 is going to be equal to opposite over adjacent. 5 over x. I'm going to multiply both sides by x and then divide by tangent of 36. So I'll get 5 divided by tangent of 36. And so making sure that my calculator is in degree mode, I'm going to go check on my calculator and I'm going to get my apothem x to be 6.8819. So notice I'm not rounding it till the very end. Okay, I know my apothem, and so now I can go find the area of this polygon. Area of my polygon is 1/2 times my apothem, 6.8819, times my perimeter. And remember, we talked about how you can find the perimeter by taking the side length, which is 10, and then we're going to multiply that by the number of sides. This is a 5-sided polygon. So my perimeter is 10 plus 10 plus 10 plus 10 plus 10, 10 times 5, 50. I can just go type all of this into my calculator. Remember, I'm using this long, crazy decimal that's stored in my calculator instead of rounding it. And so the area of this pentagon is 172, let's round to the nearest 100.05. And my units, since it's area, are inches squared. The area of this regular pentagon is 172.05.